Hello everyone, welcome to another one of my Leetcode videos. In this one we'll do Leetcode 983, minimum cost for tickets. This is today's daily challenge. So we're basically given two arrays. One is the number of days we want to travel, or the days we want to travel, and the other one is the cost, which is basically the cost of a 1-day pass, a 7-day pass, and a 30-day pass respectively, right? So we need to determine the optimal passes that we should purchase if these are the days we want to travel. So basically in this example, we're given, let's say, these are the dates we want to travel, and this is the costs for a pass. So one thing you could do is on each day, you get a 1-day pass, right? So it'll be $2 here, $2 here, $2 here, up all the way up to here. So in total, you'll pay $12, right? The other option is on this day, you can get 30-day pass, right, for $15, and for $15 you'll be covered up to the end, right? And then the other option is you get, let's say, a 7-day pass at day 1, and then that sets you good to day 7, and then you buy two 1-day passes, right? So that'll be 7 plus 2 plus 2, which is 11, and that is actually the optimal one. But you could also just buy a 1-day pass here and a 1-day pass here, and then do the 7 days in between. In either case, 11 is the smallest amount. So what will be your approach to solve this problem? If you think about this one, this is basically going to be a dynamic programming question, right? Like, because you have to explore different possibilities and you have to optimize for the minimum. So what we'll try to come up with is, what are the different parameters? What is our recurrence relation, right? Like, what is our subproblems? And then we'll try to see what we can do from there. So basically, if you look at this, what are our variables, right? So for example, given this input, you need to know at each point, like, up to when is your last pass good until, right? Because it might be that when we visit this day, we already purchased a 7-day pass, let's say here, and turns out that we don't need to do anything here, right? That's always optimum if the last thing we purchased covers us. So then we just move on, right? So we need to know when the last pass is good until, right? And if the last pass doesn't cover us, then we have 3 decisions to make, right? So either we take a 1-day pass, a 7-day pass, or a 30 days pass, right? And we have to take basically the min of these 3 decisions, and whatever is the most optimal, that will be the number of cost, the minimum cost it takes to go from that day to the end if we don't already have a pass that's good for that day, right? And so if we do this, there can be still repeating subproblems, right? Because let's say you pay for a 1-day pass on each time. At 8, you still have a problem. Okay, if I don't have a pass at 8, what's the best I can do to get from 8 to 20? And then if you do the other option here, which is to pay for a 7-day pass, the 7-day pass will be good from 1 to 7, but you'll still have another subproblem here, which is the same one as last time, right? So we'll basically memoize whatever we decide here in a DP array, and that will represent basically the time it takes for this index if we start here to get to the last day, right? Which will be the min of these 3 decisions. And one other thing I wanted to highlight here is note that the array is going to be sorted, right? So we're given here that days is in increasing order, so we don't have to worry about sorting it ourselves or days being out of order. So with that, let's just go ahead and code the solution, and then we'll see hopefully how things unfold. So basically, we'll do a recursive function, right? So let's write our recursive function, which will basically be int min cost tickets, and we'll take in obviously the inputs, which is the days and the costs. We'll take in what index we're at right now, right? What index we're starting at. We'll take in this variable which we'll need, which tells us when is the last pass good up to, right? And we'll also take in our DP array, which will tell us what is the minimum way to travel from this index to the last day. so that we avoid, having to solve the same problem twice. So first, let's handle our base case, right? So the base case again is if our index is greater than or equal to days length, that means, we've already been through everything and we're trying to go to the next one. That means, we're done. So then we just return 0 because you don't have to spend anything because you're already at the end. So you don't have to spend anything to reach to the end, right? And so the next thing we will check is if our day set index is less than or equal to our last pass good until. That means if the last pass still covers the current day, then we just skip it because it's always optimal to just use that and move on to the next day, right? So in this case, we'll just recurse for the next index, right? Because our last pass is still good. So we'll just go ahead and recurse. And then next case is so now our last pass is not good, right? Because we've already checked that here. So now if we've already computed the minimum way to travel to the last day, right? If we start at this day, that means dp at index would not be equal to 0, right? Because initially we'll initialize everything to 0 and we're guaranteed that the cost is at least going to be 1, right? So there can't be a 0 cost option. So therefore dp at index being 0 means we haven't computed it yet, the cost. And so if it's not 0, we'll just return dp index, means we've already computed it, right? And otherwise, what we'll do is now we'll make a decision, right? So we'll take the minimum of these 3 decisions. So we'll compute our min cost. And then what we'll do is we'll set our dp at index equal to this min cost. And we'll return the min cost, right? So the min cost now will be the minimum of these 3 decisions, right? So we'll say math.min, and then all the 3 decisions, right? So let's just copy this one over here 3 times and change the variables, right? So all of them will try to go to the next day, right? But so the first option is if you pick the 1-day pass, right? So you'll have to pay the cost of picking a 1-day pass, which is cost at 0, right? That's the cost of picking that 1-day pass. And then your last pass good until will just be days at index, right? Because we can only use this pass for today. We can't use it for tomorrow. So whatever the current day is, the pass is only good for that day. The next option is if we pick a 7-day pass, right? So we'll say costs at 1, which is the price of a 7-day pass. And this time the last pass is good until days at index plus 6, right? Because it includes the current day. So the current day will become the first day you use it, and then you can use it for current day plus 6. And the same logic over here, where we'll say cost at 2 for the 30-day pass. And this time it's good until days at index plus 29, right? Because it's a 30-day pass including the current day. It's current day plus 29. So whatever the minimum of these 3 options will be the minimum cost, and that will store in our dp array. So now we just have to go ahead and call this function. So we'll say min costs, days, costs, start at index 0. Our last pass is good until 0 because we don't have one. And then dp will just be new int of days.length. So whatever this days array is, we'll have a dp for each position, right? And finally, whatever we return will be our solution. So this should do it. Let's go ahead and run it to see how this does. All right, let me just remove this scratch pad. All right, we can't take a min of 3 things at once, so we'll take a min of the first one and do another min over here. All right, accepted. Let's submit. Perfect, 100% solution. Thanks so much for watching. I'll see you in the next video. Cheers.